7th graders, it's Mrs. Trombley. We are starting chapter 2. It's all about linear relationships or linear functions. And our first lesson today, we're just going to talk about the general characteristics of linear relationships, how to identify linear relationships from a table, a graph, an equation, and we're going to talk specifically about slope-intercept form. And this is the y equals mx plus b form that I think you're a little bit familiar with from the past. And I'll introduce you to some other forms. Yes, there are 2 other forms of linear relationships. And we'll talk about how to identify slope and y-intercept and all kinds of good stuff. So let's do it. First off, what is a linear equation? I know you kind of already know some of this. It's an equation whose graph is a line. So if you look at a graph and it's a straight line, we know there's a linear relationship. Every single point on that line is a solution of the equation. So lines are made up of an infinite number of points. Now we're used to highlighting those that are nice whole number points, but every single little point in between is actually a solution. Alright, if you're looking at an equation and trying to figure out is this linear or not, I know that we did this a little bit with the shapes of algebra, but just to kind of highlight that again, in a linear equation, x and y both have an exponent of 1, meaning you're not going to see an exponent after it. If something has an exponent of 1, you don't write the 1. It's kind of like with positive numbers, we don't put a little plus sign in front of a positive number. When an exponent's 1, you don't put a little 1 in front of it. Alright, x and y can't be multiplied together, so you won't see x and y next to one another. Who wants to stand next to their x anyway, right? Anyhow, x and y also won't appear in any denominators. It didn't say numerator, because that's possible. But x and y won't appear in the denominator, they won't appear as an exponent, and they won't appear underneath any radical signs. So all those ways you've already explored, I'm just kind of recapping them. So just a little example here of linear versus not linear. Right here, I know it's not y equals mx plus b. The equation doesn't have to be in the form of y equals mx plus b. There are other forms. They just have to fit these criteria up here. So if you're looking, all of these equations, x and y don't have an exponent after it, right? There's no exponents. So that means they're linear, step 1. X and y also, I don't see anywhere where x and y are directly next to each other. Here they're both on the same side, but they're not being multiplied together. They're not right next to one another. And also I don't see x or y underneath any radical signs, and I don't see x or y in any denominators. All of those are linear, even though they're not in the form of y equals mx plus b. These are non-linear examples, and if you're looking at this first one, try to pinpoint before I tell you, what about this equation makes it not linear? Is it the x and y that you see right here that are being multiplied together? That's what I noticed. So that's what makes this not linear. In this one, what do you see? What's wrong with this one that it's not linear? If you said that x has an exponent of 3, you are correct. X is not allowed to have any exponents other than 1. What's wrong with this last one? Yeah, I have a y in the denominator, and x and y are not allowed to be in the denominator. So our step 1, can you look at an equation and tell me if it's linear or not? I think you can. And if you need to review, it's these 3 criteria. All 3 have to be true for it to be linear. All right. You can also look at a table and identify if it's linear or not linear. And in a table, an easy way to identify it, if there is a constant rate of change, it's linear. Because if something's going up or down by the same amount, it's going to make a straight line on a graph. It just happens. And my words for constant rate of change to remember are CROC, constant rate of change. So the tables have a CROC, and that's how you can tell. So again, I have an example of a linear relationship shown and a non-linear. So take a look. With this first one, figuring out a constant rate of change, the rate of change is just what it goes up by or down by. So x will have a constant rate of change, and y will have its own constant rate of change. They don't have to be the same numbers, but across x needs to be the same, and across y needs to be the same. So in this one, to get from 2 to 5, I add 3. And to get from 5 to 8, I add 3. And I'm not looking for multiplication relationships here. I'm looking for what do I add to each number, or what do I subtract from each number? Because what something goes up by or down by, that's what I'm looking for. So 8 plus 3, 11 plus 3. So right now, x has a constant rate of change. That's not enough. I need to make sure y does as well. To get from 4 to 3, we take away 1. 3 to 2, take away 1, or add -1, you know, whatever. And we take away 1, and we take away 1. So x has a constant rate of change, y has a constant rate of change. This is linear. An example of a table that shows a non-linear relationship, take a look up here for the x. To get from -2 to -1, you're actually adding 1, because -2 plus 1 is -1. And -1 plus 1 is 0, and 0 plus 1 is 1, and 1 plus 1 is 2. So far, checking that, you might think, well, wait a minute, that's linear. X has a constant rate of change, but y has to have a constant rate of change too. So to get from 7 to 6, you take away 1. To get from 6 to 4, you take away 2. And from 4 to 1, we take away 3. And to get from 1 to -3, you're taking away 4. Do you see how this number is not the same? That means this is not linear. This needs to go up or down by the same amount. I know there's a pattern here, but it's not a linear pattern. So that's how you would identify a linear relationship from a table. All right, we already talked about graph. It's a straight line. The end. Okay, here are the 3 forms, and we're going to explore all of these in this chapter. But like I said, for today, the first one we're going to really look at is this slope-intercept form, y equals mx plus b. And you might be thinking, well, why on earth are there 3 versions of the same kind of relationship? I don't get it. Well, each version kind of serves its own purpose, depending on what you're looking for. So if an equation is written in y equals mx plus b, or slope-intercept form, m is the slope, b is the y-intercept. That's why it's called slope-intercept. Crazy, I know. You know the slope and the y-intercept with this one. So if you're trying to easily identify the slope and the y-intercept, maybe to graph an equation, you'd want it in this form. There's another form of it called the standard form. And the standard form is ax plus by equals c. X and y are always going to stay letters, and a, b, c get replaced with numbers. The thing is, a and b can't both be 0. Because if a and b were both 0, wouldn't x and y be gone? Yeah, that would be a problem. You need an x and a y in a linear relationship, or there's no relationship. This kind of equation is used when you want to quickly identify the x and y intercepts. So in this equation, it's really, really super easy to figure out where the graph crosses the y and where the graph crosses the x, and that allows you to graph it quite quickly. The last form we're going to learn about in this chapter is the point-slope form. And in the point-slope form, and it looks kind of crazy, but in this one, the m is still the slope, and this y1 here and this x1 here, that just represents an ordered pair that's a solution point on the line. So if you're given the slope and you're given an ordered pair that's a solution point, you can use a point-slope form. So this is what used when you know the slope and a solution point. You can set it up into that equation. And all these can be rearranged back into y equals mx plus b. So, sorry, coffee. All right, so move on to the next page. Slope-intercept form. Okay, so yes, you're going to be super duper familiar with y equals mx plus b if you aren't already. But in this slope-intercept form, again, it's called slope-intercept because you're given the slope and the intercept in this. And the slope, what the slope represents about this. The slope, or m, in y equals mx plus b represents the slope. It determines how steep your line is going to be. The greater the digit, the steeper the line. So the slope is basically that rate, and it tells you what your graph's going to go up by. Doesn't it make sense that something that tells you what your graph goes up by or down by determines the steepness? I know, it's perfect sense. All right, you can find the slope quite easily because it's always going to be in front of the x, right? So that's how you find it. Look for the x, and the coefficient of x is your slope. If the m is positive, that means that your graph is going to go up from left to right. So your line's going to end up looking like that. If your slope's negative, that means that your data is going down, like in the Twizzlers after you took each bite, the length went down. Equations that have the same exact slope, and you probably saw this from calculator lab, end up being parallel to each other. So if an equation has the same exact same exact m, but different b's, they're going to end up being parallel. They'll never touch. Can't touch this. Okay, a little bit about the b. We have to talk about the y-intercept too. Don't want to leave it out. The b in y equals mx plus b is the point where the graph crosses the y-axis, the vertical axis. The b will not have a variable next to it, so it's the one that's by itself. So remember that b equals by itself. That's how you can find it. The fancy term is it's called a constant. If an equation doesn't have a b, meaning it's just y equals mx, and there's no plus b, it actually means that there is a b, it just happens to be 0. Because if you take mx plus 0, isn't it still mx? Yes. And maybe last year you remember this as direct variation or a proportional relationship. If you don't remember that, we will be talking about it, so don't you worry. Don't you worry about a thing. Alright, anyhow, I'm talking to myself too. It's a beautiful song. So our key concept right now, why am I telling you all this? Well, if an equation's written in slope-intercept form, you can use it to identify the slope and the y-intercept quite easily, and that's what I want you to be able to do first today. I want you to be able to look at an equation and tell me the slope and the y-intercept, because that's going to help us later on in section 2-3 when I ask you to graph these things just based on an equation. So let's try it. Now you see all these crazy examples over here. It's actually not going to take too long, so don't be in a panic. Okay, so if your equation is written in the form of y equals mx plus b, you can identify the m and the b. If it's not in y equals mx plus b form, you can't just look at it and tell me the m and the b. But you learned in chapter 1 how to rearrange equations, right? So if it's not solved for y, if it's not in that function form, you can easily mix it around and solve it for y, those literal equations. So what I'm going to ask you about each one of these equations is, what's the slope, what's the y-intercept, and is this a line that's increasing or decreasing? Meaning, does this line go up to the right or does it go down to the right? Okay, so first equation, we're going to check to make sure it's solved for y, and yay, it's already solved for y. Y is by itself on one side. It doesn't have to be on the left. Okay, it doesn't have to be, it's okay. So in this one, to find the slope, I said slope is always going to be next to x, so your slope would be 7. And your y-intercept, the one that's by itself, right here, it's plus 5. That makes this a positive 5. But I don't want you to just write 5, because the y-intercept is a point on the line, right? So you're going to list that ordered pair for me. And do you have to? Yes, you have to. Thank you. Then you make the connection that, oh, this is actually a point. And then you don't confuse the slope and the y-intercept. Trust me, I've been doing this for years. Okay, now, is this increasing or decreasing? If your slope is positive, then it's increasing. If your slope is negative, then it's decreasing. So increasing and decreasing is completely based on what your slope is. So look at your slope to figure this one out. See how it's a positive 7? That means this is increasing. I will let you just write that, because I didn't give you enough space to fill it all in there. There just wasn't enough room. All right, look at the next one. Do you see how y is by itself right here? That means we're good to go. I don't have to rearrange anything. I just need y alone. So now let's look at the other side here. The coefficient of x is 9. That makes that my slope. The number that's by itself is a positive 2. That makes my y-intercept 0, 2. And since my slope is positive, yes, this is increasing. Okay, next one, I see y is already alone. Awesome. When I'm looking for my slope, the coefficient of x is a negative 10. Lovely. For my y-intercept, I don't see a plus b, right? But if you wrote this, would that change the value of it at all? No, if you have plus 0 on there, that doesn't change anything. So, when you don't see a plus b, you're adding nothing. That means your y-intercept is 0, 0. So that's where this graph would cross the y-axis. My slope is negative here. That means that my line is decreasing. It's going to be heading down. All right, next one. Yay, it's already solved for y. So many of them are. I was nice to you this time. The ones where there's more space, those are the ones we need to rearrange. So anyhow, in looking at this one, a lot of people initially tell me, oh, your slope is 2, because 2 is the coefficient of x. Do you see how this is 3 minus 2x? That actually means that this is a negative slope. So if you keep change, you won't forget that. So negative 2 is my slope. The number by itself is a 3, so that makes my y-intercept 0, 3. And since my slope is negative, this is decreasing. All right, next, oh boy. I see the x here. Y is by itself already. Great. And all I see is an x, and I don't see that x has a number in front of it. So many people write x here for slope. Slope is supposed to be a number, right? The x and y, they stay letters, and m and b are replaced with numbers. So when there's not a number in front of the letter, do you remember what we know is there? I hope. Yes, it's a 1. 1x is the same as x, right? So if you see that x doesn't have a coefficient, it really does. It's a 1. Kind of like this is x to the first power, but we don't write the little 1 there. So write a 1 there for your slope. And then your b isn't 10. This says x minus 10 or plus negative 10. That makes my y-intercept 0, negative 10. Positive slope, increasing. Okay, this next one looks kind of crazy, doesn't it? I have just y equals x. It's already solved for y, so that's great. What's the coefficient of x? I don't even see an x. My slope's not 8 because 8 doesn't have an x next to it, right? The 8's all by itself, so I do know that makes that the y-intercept, right? The number by itself is the y-intercept. I don't see an x. When you don't see an x, let me ask you this. Just like here when we said plus 0 doesn't change anything. If I wrote plus 0x, would that change anything? No, multiplying something by 0 gives you 0, and adding 0 to 8 still gives you 8. So if you don't see an mx in your equation, it actually means that the slope is 0. Think about what that might look like. Something with no slope. Yeah, it's just a horizontal line. All right, so if you have a horizontal line, right, with no slope, that graph's not going up and it's not going down. So it's not increasing or decreasing. So we're going to write neither here. That happens sometimes. Sorry, I didn't make my H tall enough. All right, next. Yep, these are all the weird ones. I always save the best ones for last, right? Okay, so in this one, the y's already by itself. I'll start with the b again because I see I'm adding 2 and that one's by itself, and this is a little different, so hold off on that. Okay, so with this one, I say that the coefficient of x is a slope, right? Well, what on earth does this mean? Okay, if you see x in the numerator spot, it's allowed, it's linear. X just isn't allowed to be in the bottom. What did we say was really in front of the x when there wasn't a number there? A 1, right? So, are you seeing the slope now? The slope in this one is 1/5. 1/5. So if you see an x in the coefficient spot, it looks like a little fraction there. It is a fraction. It's 1/5. All right. And as far as increasing or decreasing, I know it's a fraction, but it's not negative, so it's increasing. Okay, another fractional kind of weird one here. Y is already by itself. Great. I see it's 6 minus 3/5 x. I'm going to keep change, so I have all my signs right. And what's the coefficient of x? It's negative 3/5. So your slope is negative 3/5. The number by itself is 6, so my y-intercept is 0, 6. Since my slope is negative, this is decreasing. Okay, now we're to the big box one where we need some space. We need some space because in looking at this, my slope, I can't just say my slope is negative 3 and my y-intercept is negative 2. You need to solve this for y because it has to be in slope-intercept form in order to easily identify the m and the b. So let's get this y by itself. We do that by adding 2 to each side. So we're left with, I'm going to write it down here, y equals negative 3x plus 2. Those aren't like terms, so I can't combine them. Now we can go ahead and say, oh, the coefficient of x is negative 3. The number by itself is 2. Negative slope means decreasing. And last one like this, we're almost there. We still have a few more things to do, but the introductory lessons are the longest, I know. Okay, I'm going to keep change. Y isn't solved for y. It's not by itself. So to solve this for y, I'm first going to get rid of a 6. Yes, you need to do that first. So you're left with 2y equals 3x plus 6. Now, y still isn't alone. It's got this little 2 in front of it. So I'm going to divide by 2. That means I need to divide each term by 2. So y equals, and what's great about slope is you actually can leave things as improper fractions. And we'll talk about that in the next lesson of rise over run. So I'm going to leave this as 3/2 x. If you have to write 1.5 or 1.5, go ahead. For now, that's fine. And 6 divided by 2 is 3. Now it's solved for y. Now I can say, okay, the slope, the number in front of the x, is 3/2. The b, the number by itself, is 3. And that's a positive 3/2, so that means this is increasing. So now we know how to identify the slope and y-intercept from an equation. One last little part. I know, I'm sorry, you're almost there. We'll probably do most of these in class together, and I'll send you home with the rest. Okay, so writing linear equations in slope-intercept form. I'm going to ask you to, given a verbal situation, give me the equation that represents that verbal situation. And traditionally, people have kind of a harder time with this. It doesn't have to be that difficult. So I got some helpful hints here to help you through. First off, keep the following in mind when you're writing an equation in y equals mx plus b form. The x and the y are always going to stay x and y. They represent the independent and dependent variables. So in your equation, y and x should be there. You don't change them. The m and the b are going to be replaced with numbers. So when you write an equation for me, you're not going to see an m or a b. You're just going to see a y and an x, and the m and b are going to be numbers. The b, kind of look at that as the starting point. It doesn't depend on anything. It always stays the same. It's the constant in your life. It's how long the Twizzler was before you took a bite. It's the starting point, the number by itself. So as you're looking at these verbal situations, think about what's the starting point. That's your b. Now, whatever rate that you're given, that's the m. That's what your graph is going to increase or decrease by. So rate per something. The m depends on the x. The value of mx is going to change based on whatever x is. So the number that tells you what it goes up or down by, that's your m. The number that you start with, that's your b. So let's try just a couple. I only have 3 little problems. Okay, I have $100 in my savings account. Each week I deposit $10. So what's the amount that you start with? That's the 100, right? And the number that it's going to go up or down by, it says each week I deposit $10. That means every week this is happening over and over again. So it's going to go up by 10 because deposit means put the money in. So that's your m. So if you know your b and you know your m, all you need to do now is replace them in y equals mx plus b. Y equals m is 10, x plus 100. It's that simple. All right, let's try another one. Or maybe you want to pause and try these 2 and then unpause and see if you're right. You could do that. Or not, whatever works for you. Okay, I have $200 in my savings account. Each week, I withdraw $15. So the amount of money that you start with in your bank account, that's the $200 right there. Every single week, I'm taking 15 out because withdraw means take money away. So this 15 is happening over and over and over again. But if I'm taking the money out, think about what kind of 15 that is. If you're taking away, it means it's a negative 15. So I'm going to write m equals negative 15 because that's what a withdrawal means. And now in my equation, I would say y equals the amount I'm taking out, negative 15, times the number of weeks, plus the 200 we start with. So it is possible to have a negative slope. We just did that in the previous page. It's okay. Okay, last one here. Yes, the last one, thank goodness. I lend my friend $50 each month to help her pay her bills. It's so nice. So with this one, the starting point doesn't really tell you what the starting point is. It just tells you that every single week you're lending $50, right? So that would be the slope, that rate. And I guess you can kind of look at this in 2 ways if you're trying to write an equation. Like, should the 50 be positive or negative? If you're looking at the total amount of money you give your friend, you would keep it positive. If you're looking at the amount of money you have left, you would look at it as negative. So I'm just going to look at this as the total amount of money I give my friend, which would be y equals 50 times the number of months that I have lent my friend money. The end. Good job.